The new component that we introduce belongs to the hydraulic brake system library. That means that this element can be used with another elements of this hydraulic brake system. Main goal of this element to control the braking system to achieve a stabilization effect in case of some vehicle maneuvers. In this particular case, we simulate the following situation that I hope it's not a typical situation for all of us, but it can happen that if you are driving, we need to control the car in another direction, and we have in this case some assistant that can help us to stabilize the. In this case, we see a car and try to move the car to the left, and so we can see that in this case, ESP controller that we use here helps us. So it brake the wheels on the one side, on the corresponding side of the car, to achieve a stabilizing effect, and helps driver to not lose control. So now I will start also the animation to see this effect smoother and to analyze this effect maybe more deeply. So, for example, in this case, as we see that driver tried to move left and the system analyze the situation. So this system contain virtual model of the car and analyze and predict dynamics of the car. If driver move car too fast to the left, we try to compensate this with a corresponding torque and brake the wheels on the right side. If you move forward and see the driver try to overcompensate this drift, the system analyzes the situation and compensate torque in another direction to prevent losing of control. Yeah, and also for last side and for the last part of this maneuver. And of course, user have a possibility to switch on or switch off the situation, switch off the controller, ESP controller. We have a lot of possibilities to set this, parameterize this. For example, we can define if you want to control the two wheels or only one wheel. We can also define brake torque distribution between the front and rear axis. And of course, we have a lot of possibilities to feed controller of the ESP controller. We also have a possibility to consider the sleep engine control. The parameterization, the connection between ESP controller and the vehicle is we try to make it so easy as possible. At the end, user of course have to connect the vehicle model and the ESP controller to provide controller with all of needed information about vehicle geometry. But of course, user can do this with just referencing with the corresponding parameters of the car. We try to make it really friendly for user to name the parameters in the same way than in the vehicle and so on. And as a result, user can also analyze torque results, of course, and control signals that we send to the brake system. The main idea is also that we can connect this with a hydraulic system. Now, for the better performance, for the sample model, we simulated this system without a hydraulic system to achieve better performance for the sample model. But of course, at the end, user can connect this controller with a hydraulic system and achieve a really accurate result, and with considering of all of the hydraulic processes that happens in the hydraulic system. For this purpose, for example, we have also corresponding parameters that are meaningful for hydraulic system. For example, the maximum circuit brake pressure for ESP activation and so on. At the end, we have a really powerful new element that we introduce for the hydraulic brake system that allows user to really to use all of the positive side of multi-physical simulation So we can simulate also vehicle dynamics in a detailed vehicle dynamics. We can simulate the hydraulics, and we can also simulate a really powerful ESP controller, and user can use this element out of the box, just connecting with a vehicle and hydraulic system. And I think it's a really great feature for users that want to use all of the positive things of SimulationX multi-physical simulation.